Hey folks, my name's Tyler Crow and welcome to Cloud on Air. I'm a senior product manager here at Google Cloud and I am super excited today to tell you about this awesome product that we just rolled out recently called Firebase Data Connect. I work here on the Firebase team and I manage the Firebase database products. So without further ado, let's dive right in. So Firebase Data Connect is our new product that we just rolled out to help customers accelerate their app development and build really immersive, great experiences for their customers. We rolled out our public preview in October of just last year, and today we're going to dive in to what the product is, how it works, and we're going to even get to see a demo live of all the different inner workings of it. So what does Data Connect do? Well, Data Connect helps you accelerate your app development and build generative AI experiences. So to start off, if you want to use Data Connect, it's going to connect to your Cloud SQL for Postgres instance. And this will then connect to your client application. So you can think of it as this really powerful serving layer that will translate your data out to your client and back. So you start with your client SDK on your client app, and when you want to read or write data from the client to power that customer experience, it will execute that against the Data Connect service. And it has built-in authentication and authorization using the Firebase Authentication product, which will allow you to create secure, immersive experiences. The Data Connect service then takes that query that was executed from the client, translates it into underlying SQL, which executes in Postgres against Cloud SQL's underlying database, and pulls out the relevant content and passes it back to the client. Now, that's it. It's really simple, but let's talk about why we built this. We built Data Connect on a single principle. You write the query, we do the rest. So what does that mean? Well, when you write your query and define it in Data Connect on that service, we generate for you a secure API endpoint with that built-in authentication check and an authorization policy that you define for that query. We generate you type-safe SDKs to call into that API endpoint, which makes it really easy to get going and hit the ground running. And we also generate tool definitions. So if you want to build agentic applications with generative AI that's going to call in and talk to your database, tool definitions you can think of as kind of a client SDK for an LLM to call into your system. So we have defined and kind of pioneered this concept called query-defined infrastructure. So you'll see here on screen that this is a definition of my schema. And this is just one table that's defined in my schema called announcements. And this table, along with this query that I've defined, define my infrastructure. So I can focus on my business logic, defining my schema and my queries, and Data Connect handles the infrastructure and the rest. So from my schema, we generate the underlying SQL DDL to match. So the Cloud SQL instance will have the matching schema. We also generate that API endpoint, which can be called into to access that data from the query. And we even generate that type-safe SDK. So that type-safe SDK is just one line, and it can really easily just pull that data out of the database and power your client experience. So I mentioned earlier that we built this product with generative AI experiences in mind. We want customers to be able to have those immersive experiences. And to do that, you need retrieval augmented generation. Now, what does that mean? In this case, if I ask the AI, if I have a customer and I'm building an AI experience, I may have a prompt which I'll pass to the AI and it'll give me a response. The problem is that if I pass it to Vertex, it's not trained on the data in my database. And even if we did decide to train it and fine-tune it, that data is constantly changing and ever evolving. And you want the AI to be up to date on the latest things that are happening within your database. That's where retrieval augmented generation comes in. What we can do is we can generate embeddings for the data within my database execute vector searches using that prompt that came in. And that way we can extract the relevant data within our database, pass it to our AI along with the prompt to give relevant outputs to the based on what the customer asked for from our database. That's a major step up, and it makes the AI seem intelligent because it understands the data in your database. So we've covered the broad strokes of what Data Connect is and what it can do for you. Let's dive in to a demo to see what we can do with it and the power. So we're going to transition over to my laptop here, and we're going to go through a live demo to see what it does. So we're going to start in the Firebase console. This is our command center, and you'll notice here, this is my Data Connect service. I can ask Gemini to help me understand what it does. And you'll notice that we're looking at the schema, right? The foundation of any application is how is my data structured for my application. And this is a standard, right, kind of relational database where things are normalized. You'll notice the app that we're building, I'll give you a little sneak peek. This is my deployed production app, is a movie review app. So I can log in, I can leave reviews about my apps. If we go over to my profile, I have even favorited movies. I've left a review from one of my favorite movies. I can pop into movies. I can check out what actors are associated with the movies and what other movies they've been in. This is our application that we've built today, and it's actually the code lab for our product. So if you want to try this at home, you can dive right into this and use everything you see here today in 30 minutes at no cost. So let's jump back and look at our schema. So you'll notice here we have some really core tables, right? We have the movie table. That is going to be one of those core entities that allows customers to review and look at all the movies within the database. You'll notice here we've got our actors, we've got our users, and then we've got a bunch of tables that are keyed off of, right, like the movie metadata is keyed off the movies, reviews are keyed off of both the movie and the user. Now we can explore this data by just clicking View Data, and this will take us to our Data Exploration tab, which allows us to execute arbitrary GraphQL queries from our console. So embeddings are gigantic, so we're going to remove those because it makes the results hard to parse. And look at that. I just executed a single query right there based on what was generated for me, and we get a JSON blob of all of those objects that were returned based on this object structure that we defined here, query movies, and then all of these fields within the movie. And you'll notice here we have the first movie is Lone Outlaw. I'm actually going to steal the ID really quick. So let me copy that. You've noticed that the input was this operation, and you can even pass in what variables and authentication you want to run as, and we have a history of our executions. Now, let's go take a back and look at these operations, right? This is our query-defined infrastructure. These are those APIs that power our application. So you'll notice when we looked back over here, right, there's our homepage, which has a list of top movies and latest movies, but you can click into a movie and actually see the information about a movie, the main actors, supporting actors, a description. All of these don't exist within the movie table. They require some joins. So we can actually go look at our Get Movie by ID, and looking at the Get Movie by ID here, you'll notice that these are the associated tables that it's pulling from. So in order to pull this data out, this might seem like a complex SQL query, but if we do it with our GraphQL, you'll notice that we're doing a movie query, we need the UID of a movie, and we have our authentication level set to public. Now, when we query against the movies with the ID, it will pull out the same fields that we saw previously, but you'll also see that we have these underscore on movies, underscore actors via movie actor. These are built in and are generated. It's an GraphQL ORM that's automatically generated based off my schema, which allows me to write really complex, allows me to write these joins to grab relevant information. So I can write a single request, gather all the necessary information from all of my normalized tables, and pipe it into a single response object, which is really easy to reason about and is great for client performance because it's that single request that's powering everything that's coming out there. Now, you'll notice I can go monitor this to see what's going on in my prod instance, or I can go over to run, which will take me back to my data page. And you'll notice I still have my previous movie query here, so we can get rid of that. And we have our get movie by ID. And you'll notice that it takes this ID field. So we can actually inject a variable here. And this is the lone outlaw, the one I pulled just from the previous page. Here we'll hide the docs to make this a little bit more visible. And you'll notice here we're, right, like these are what we're joining on, the role equals main, role equals supporting. And so, actually, no, these are where clauses, excuse me. Once we run this, you'll notice that we'll get an output of what this object is, and this is a Celestial Harmony. Great, okay. So I actually copied the ID for Celestial Harmony. I didn't copy the one for Lone Outlaw, but we still got the right results here, which is what's important. And so now that we've seen this in action, and we've seen what this looks like, we can actually also craft some queries using Gemini, right? So let's say I'm not the most familiar with my GraphQL, and so I can actually use Gemini to generate a query based on natural language. So let's say, show me the top 5 the movies in order of rating, descending, and let's try to paginated with 5 per option. And let's see Gemini take my poorly worded request and create a query for me. So you'll notice here that I can go and edit this if I want to tweak it, or I can insert my query based on what Gemini generated for me. So I'll see here that it's looking for movies, it's ordering by rating descending, so it's going to have the highest rated thing first, limit 5, and then offset 0 for pagination. So we can insert this, and it looks like it works correctly, which is great. So I can run this, and if we look at this, here we see, okay, the highest rated movie within our database is Phoenix Rising, rating 8.6, and there we go. And one of the great things here is with this pagination, I can say, okay, let's go to the next 5 with this cursor that we're using, and there's the next 5 options. So one of the things that's great here is we use Gemini to help us learn about how we can craft queries against our schema if we're unfamiliar here. And this will help us grow, and I for me, personally love it as a tool to help me learn about like what I could do. I initially didn't start off as a great GraphQL expert, and this has helped me cover some of my bases and learn and quickly get into the product. So, one of the great things that we've built about this product is, yes, we have this in production, but when you are building an app, you need great local tools. And so let's transition over to see where I've written this all. This is my VS Code instance, and we built an extension called the Firebase Data Connect extension. You'll see here that I'm actually running a local version of all of my services. So I have not only Data Connect, I also have a local version of Firebase Authentication running. I also have a local version of Firebase Hosting running. So if we go over to here, we can see that I've got localhost 5173, and you'll notice it's pretty empty. So we can refresh this, and it's empty. So this is running on my local machine, local versions. And what's great is this is basically a sandbox where I get to play around, rapidly iterate on features, see what it's gonna look like before I push things to production. So let's check out what kind of power we have here. So the first thing we need to do is we need to populate our local instances with data. And here you'll notice I've got some mutations that will populate the data for the app. And you'll notice here there are these code lenses. I'm going to zoom in really quick so you can see that. There's this run local code lens and run production, which means you can actually execute this mutation against my local instances or against my production instance using my production credentials that I've logged into. You'll notice here in the Data Connect extension that I'm actually logged in as myself on my production project. So I'm going to run this. I'm going to zoom back out so you can see. I'm going to run this locally, and you'll notice here we actually have a Data Connect execution panel. And this looks very familiar because it should look a lot like our console execution. We have our results, we have the history of our executions, and we have variables authentication that we can inject into the request so we can make sure it's got the right parameters. Now, if we jump back to our web app, I can hit refresh, and voila, we've populated that data for our local instances. Now, the other thing that we had that's really powerful was vector search for retrieval augmented generation. Now, in order to do that, let's take some steps to better look at how that works. So we're going to add some more mutations in, and I'm going to make this a little bit bigger so folks can see this. And so you'll notice here we're going to update our movies, and we're going to generate our embeddings. So you'll notice here this underscore embed is a server value, which indicates to Data Connect that you should execute this, go talk to Vertex AI, and generate an embedding using the text embedding Gecko 003 model on Vertex AI for this set of text. And these sets of text are the descriptions for the movies that we have within our application. So once these embeddings are generated, we can then do vector searches with embeddings to look at this text to say, hey, does the LLM think that this text is related to what the user is requesting? And once they do that request, then we can get the relevant movies based on the user's request. And I'll show you what that looks like in just a second. So let's run this locally. This is going to take a little bit longer because we're talking to Vertex AI. We're generating all those movie embeddings and we're inserting it into our local database. So those have all been inserted, and we can go over and look at our friendly movies here. We can go to vector search, and let's look for sci-fi movies with space travel. So if I execute that search, actually let's go, before I steal all my thunder, I was getting ahead of myself. Let's go look at the query that makes this possible. So this was our favorite Get Movie by ID query that we saw in the console already. Here is one where we execute a vector search. So you'll notice this underscore similarity. That is an indication that we want to run a vector search within our Cloud SQL instance. That underscore similarity allows you to take an embedding and compare it to other embeddings to see if the LLM thinks these objects are related. A good example might be if I'm looking for a vacation, I've got a museum, a mountain, and a beach, and if I say the word skiing, the LLM knows that the skiing is more closely related to the mountain, so the mountain results will come back instead of those other ones. So in this case, we're using the same model, but what we're actually doing is we're creating an embedding, underscore embed here, for the query that we passed in. And we can set our parameters for what, how similar we want it to be and the limit on the results. So if we go look at our sample app, sci-fi movie with space travel is being converted into an embedding and then searched all against the other embeddings that are the descriptions of the movies. And so once we execute this search, it will give us movies that should have to do with space travel based on their descriptions, which is great, right? Historically, right, you used to have to tag every type of content within your database to get, this type of movie is this type of movie is that. Now you can just generate embeddings to give a more intelligent search over the data in your database. And if you want to return those results back to an LLM to give you relevant results or relevant responses to your customer, you can do that. So here with this vector search, you'll notice beyond the horizon, in the future, Earth's best pilots are sent on a mission to explore a mysterious planet beyond the solar system. That sounds like it has to do the most with space travel, which is why it's probably the first result. And you'll notice these other ones also have to do with space travel and our sci-fi movies, which is why we're getting results like this. So this gives you a really easy way to bootstrap up a search and return those relevant results from your database, no matter what type of customer is coming in and asking questions. And you can fine tune it with those parameters. So one of the great things here is we make it really easy to implement. And I actually haven't shown you what this looks like on the client code. So let's go take a quick peek at that. We'll actually go back to our favorite query, get movie by ID. And so once I have this query, get movie by ID, we talked about how this translates into a type-safe generated client SDK. So if we move over into my web app where I have my client SDK executing, I have this handler function called handle get movie by ID. And now you'll notice I have this await get movie by ID where I pass in the movie ID and it returns me a response with data that has that movie object. Now if we go inspect that movie object here, you'll notice that it looks really familiar to the query that we defined. And that is because this has defined a strongly typed object, right? It has to have an ID, has to have a title, has to have an image URL, and it can optionally have release year, genre, right? It's even got the metadata director, the main, an array of main actors, an array of supporting actors. This is a strongly typed object that's easy to reason about on the client SDK that can be called just with a single function based on that query that I wrote. So it saves you the hassle of creating the API, creating the client code to talk to it. You can focus more on your business logic, creating immersive experiences just by defining that query there. So that is the power of that query-defined infrastructure. Now, once your app is out and into production, right, you are going to have lots of users poking around, using the application. You might want to see what's going on in your application. So we have our get movie by ID, and we can actually go look and monitor to see what it's doing. And so one of the great things here is we have an overall view, and let me refresh this page really quick. So we have our overall monitoring view. This is what happened in the last 60 minutes, and in the last 24 hours, here's been the spike in usage on my application. And I have my operation count, how many times each total operations have been executed, my average latency, and the bytes sent. And then I can actually go in and inspect the get movie by ID specifically to drill down and get even more data. This data is kind of the seed to better understand how your app's performing, how specific queries are performing, and if they need to be tuned with additional indexes, performance improved, to improve that performance and get better experiences for the customers. And now you'll notice here, these have all the operations that are available, each one of these being their own separate API that can be called to give you a really detailed view of what you need to do and what you need to look at in order to better understand how your app is being used. So we've gone through a lot of content today. This is actually the end of the demo. There's a lot more here that you can uncover if you dive in a little bit deeper. So I encourage you to go check out our Code Lab online. But we actually covered what the product does today. We covered how it can help you accelerate your app development, increase your velocity, take advantage of that really powerful query-defined infrastructure so you can focus on your business logic while we help manage the infrastructure. And we learned how you can operate with your local tools to rapidly iterate, prototype, and deliver new features. So folks, that is the end of our demo. I'm sure there's some questions in the chat for Q&A. We're going to take a quick break here to go take a peek at those questions, and I'll be back live in just a couple of minutes to answer your questions that you asked in the chat on air. Hey folks, and we're back. We got a lot of great questions in the chat, so I am happy to walk through all of them. We have till the top of the hour for me to go through and answer all of your questions. So we're just gonna dive right in and hopefully I'll be able to answer all of your questions. And if not, feel free to follow up and we'll be able to follow up offline if we didn't get a great answer to your question. So the first question that we have is, how do you ensure only authenticated users can access sensitive data in Firebase Real-Time Database or Cloud Firestore? So these two products are actually not database products that we covered today with Firebase Data Connect, but I am happy to answer them as the person who manages the Firebase database products. Firebase Real-Time Database and Cloud Firestore both use a system called security rules. And the way security rules work is that those products are also directly integrated with Firebase authentication. So when you make a request from your client application to those databases, it'll pass along that authenticated client object or the authenticated user object. So a good example is like, I'm poking around in an app, I've logged in, and now Tyler Crow user with my user ID gets passed to Real-Time Database or Cloud Firestore. What you want to do then is write security rules to restrict access that only I should have to prevent me from accessing any other type of data. Now it can be a little tough because the way you write your security rules is that each rule applies to in Firestore collections or in Real-Time Database the path, and you effectively write the rule for any way data can be accessed in those collections needs to apply to every type of request that can come in. And so, for example, if I have a user profile, you want to make sure that my UID matches the UID on that user profile before allowing access. And that way it helps restrict that sensitive data to only the users who should have access to that data. If you want more information about how security rules works, I recommend exploring our documentation, checking out Firebase's YouTube channel, which has detailed, in-depth walkthroughs of how security rules work for both real-time database and Cloud Firestore. So with that, let's move on to the next question. When should you use Cloud Functions to interact with Cloud SQL from Firebase? So that's a great question, and it's something I probably didn't cover super well in the live demo as well as my presentation. When you provision Firebase Data Connect and Cloud SQL, that is just a regular Cloud SQL instance. And so Data Connect, we automatically do all the stitching to do the connection, to do the SQL queries, to manage the schema. But if you want a Cloud Function to go talk to that Cloud SQL instance, you can do that any way you want. You can write data from Cloud Functions. You can read out of that Cloud SQL instance from Cloud Functions. All of those work just as they would normally. You can even use the Postgres extensions as you like within that Cloud SQL instance. And we think it's a lot of power that you have. So Data Connect, you can think of as working with a Cloud SQL instance, not completely owning, managing it. And the great part about that is you can have all the power. So if you need a Cloud Function to go update some data in there, very easy, right? Like some server functions or some syncing of data, all of that kind of stuff can be done with Cloud Functions with that Cloud SQL instance. For client access, we think that Data Connect is probably the best way to do it. That's what it was built for. You get that strongly typed schema, the query capabilities, as well as that defined API endpoint and built-in security. But if you wanted some side paths to access that, you can also do that through Cloud Functions. Data Connect, Cloud SQL, and Cloud Functions, both of them can interact directly with the Cloud SQL instance. You can also use Cloud Functions to call in through Data Connect with more privileged access to take advantage of that GraphQL, those API endpoints. So hopefully that answered your question about what you can do with your Cloud SQL instance with Cloud Functions and Firebase Data Connect. So with that, let's move on to the next question. What are the best practices for managing user roles and permissions in Firebase? That is a great question. Fortunately, I used to help manage the security products, Firebase Authentication and Firebase AppCheck, so I have a little bit of domain knowledge here. The user roles that you're thinking about can be managed in multiple different ways, and it's going to vary from product to product. Now, Data Connect, that security model, authorizes based on operations. And so when you write your query, you actually add the security to the query itself, which is a little bit different from Cloud Firestore and Firebase Real-Time Database, where you add the security to sets of data, right? In Firestore, it's collections, and in Real-Time Database, it's on the path. Now, in order to manage roles as well as securing access, within Firebase Data Connect, we have this directive called @check, and which you can check out in @check, the @ check, which you can use to execute queries to basically query other parts of your Cloud SQL database to verify things before you allow a query or mutation to execute. And we think this is really powerful because you can store user roles in a separate table that's linked to a user, and you can query that before you allow any type of operation to proceed. You can also attach claims to Firebase Auth tokens. So for example, if I built an application that's for educational purposes, students may have like a claim that's attached to their token, their Firebase Auth token, which you can use a Cloud Function to attach claims to, that says like student, and a teacher might have one that says teacher, and that teacher can be read in that claim both on the operation, like the query in Firebase Data Connect, as well as in security rules on Firestore and Real-Time Database to verify that tag on that claim, and that can allow privileged access. For example, teachers should probably only be able to write grades, students should be able to read grades, and so you can actually differentiate based on that tag for rules on data. That's how you do it in security rules. On the operations side in Data Connect, you could actually store those roles in Cloud SQL. It'd be a little bit more challenging on Firestore and Real-Time Database. Hopefully that answers your question. If you want a more detailed guide on Firestore and Real-Time Database, I would check out some of our documentation. On Data Connect, we'll be actually coming out with probably some videos talking about how to best manage roles and groups, and so be on the lookout for those once they come out. Okay, let's take a look at the next question. How do you optimize your Cloud SQL schema for high scalability? So that's a really good question. I think that depending on the way you've structured your schema, it can vary pretty greatly. The nice thing is that Cloud SQL is just running a Postgres database. And so the standard practices for writing your schema to make it highly scalable, right? Things like managing indexes, managing your instance size, managing the amount of compute resources that it has, are all kind of standardized. You can, Cloud SQL itself has tools that can help you manage those things. So I recommend going into the Cloud Pantheon dashboard to check out what kind of tools Cloud SQL can use to help you manage that scaling. And that's one of the really nice beneficial things we love about Data Connect. It's not its own standalone database. We're taking advantage of the best Cloud SQL has to offer with all of its existing tools, and we connect you to your client app in a super seamless manner. So that would be my recommendation. If there's something more specific, I recommend following up after this. Okay, how do you prevent SQL injection attacks when interacting with Cloud SQL? That is a great question. So one of the things that maybe I didn't make as clear as I could, when you write your GraphQL for Firebase Data Connect, it is actually saved, all of those operations, the query-defined infrastructure, the queries are pre-saved. So if you are running a client application, you can't execute arbitrary GraphQL queries against the database. You can only hit the API endpoints for the queries that have been saved and defined by you, the developer. So you saw earlier that get movie by ID. That was a GraphQL query that translates into an underlying SQL query. That query is predefined and saved within Data Connect. So client applications can only execute that get movie by ID. They can't modify it and execute some arbitrary GraphQL to hit our backend. So that's actually how you prevent those SQL injection attacks. We actually don't allow arbitrary execution of GraphQL or SQL from client applications. So that way it's up to the developer to ensure that you're writing clean GraphQL that will not basically expand into a SQL injection attack. We'll have more to follow up on that on our security series for Firebase Data Connect, so keep your eyes peeled. But in terms of cleaning those inputs, I believe we are scanning for that, but that will be something I should follow up on, and I'm happy to follow up with you on that one. Okay, next question. What security measures should be taken when storing sensitive data in Cloud SQL? So that is a great question. Now, your Cloud SQL database has its own security procedures to basically lock down admin access with like a password, which you should always follow. Check out the Cloud SQL documentation for secure practices on locking down that instance. Now, obviously, you want to make sure it's connected to Data Connect because that's how your client applications will call to it. Now, the sensitive data in Cloud SQL, the way for you to monitor access to your database is actually those queries and mutations that you've defined that define the API surface. So if you want to do an audit of what client apps have access to, all you need to do is look at those operations and the security models associated with them. You saw that auth was public on getMovieById, but you may have auth level user filtering as well as auth and that at auth with expressions to basically limit what type of access is available on those operations, and that will define how you can access the data within Cloud SQL. So the security is on that per operation, aka the query or mutation basis, so it's really easy to think about. You say, okay, I'm going to open it up, my database, with these 5 queries, or whatever service you have, and those are the only touch points for access within Cloud SQL. Everything else is completely locked down. So it's only those queries that you have to think about and mutations that you have to think about locking down for your customers. Hopefully that helped answer your questions. If you want things that are more detailed, check out the security guide and our documentation. Actually, one of the things I should have done is, and I didn't, we have a Discord channel for users of Firebase Data Connect where you can actually engage with myself and the rest of our team to ask questions about what best practices. I will make sure that we've posted a link on this YouTube video, so you should be able to find it in the description. That way you can join the community and start engaging with us to ask about these types of best practices. Okay, let's go on to the next question. How can you leverage Firebase Data Connect to bridge the gap between Firebase and Cloud SQL? So this one is a bit of a confusing question for me, but I hopefully explained most of it with our... So when you say Firebase, maybe you're thinking of the database itself. So Firebase Data Connect is basically the bridge to give you the Firebase experience of connecting easily to mobile and web apps with your underlying data. And that is actually what the goal of Data Connect is, connecting your Cloud SQL data to your mobile and web clients. Data Connect, sneak preview, will not just stop at Cloud SQL. We plan on expanding to additional data sources in the future. We have something called User Voice, which is, if you Google Firebase Data Connect User Voice, there you can vote on features that you'd like in Data Connect, including additional data sources. A really good example is we have many customers who'd like to enforce a strongly typed schema for access to Firestore. And so Firestore is one of the data sources that's been highly upvoted on the User Voice. And I'm sure actually after this live stream is done, we'll be able to add that User Voice link to the description below. So next question. What are some common challenges faced by developers while using Firebase? That is a great question. I would say as Firebase, we historically have been really good at getting you up and going and getting your app built out. You prototype, you get it into a good state, you get it out into the world, and it will scale because we have that managed infrastructure that will scale to millions, billions of users. Some of the challenges that customers commonly face is that once they start to grow, their security becomes a little bit challenging. And so one of the things I recommend folks do is, like, as you're for Cloud Firestore and real-time database, as you are designing your data model, think about security from the get-go. One of the nice things about Data Connect is you actually do security per query and mutation. We use operation to call operation as a blanket word for queries and mutations. And so you can actually just do security as you go, and you just need to think about building the right schema for the data structure that you want, which is actually a little bit easier. I personally find a little bit easier. So security can be a common pitfall, as well as kind of like that groups-based access, which was that question before. And then I guess I would say like analytics is something that can be kind of a sticky point as customers' apps grow much, much larger. And that one can be covered in another session, but please follow up with us on the Discord. If you grow to that level, we'd be happy to help you. Okay, next question. When should you use Cloud Functions to interact with Cloud SQL from Firebase? Okay, I think we actually covered that one, so we should check with another question since I answered that one already. So if folks in the back could change to another question, that would be great. And maybe we are out of questions. So give us a sec while we find the next question. How do you optimize you? We've also hit this question, so give us just a second, folks. We will find any additional questions that are possible. And once we get through all of those, okay, here we go. Another new question. What are some of the upcoming trends and features in Firebase? That is a great question. So Firebase has had a really big past 12 months. At Google I/O of last year, we launched 4 new products. Excuse me. We launched Firebase Data Connect into private preview. That's the one that we talked about today that I obviously am jazzed about. We launched a new hosting service called Firebase App Hosting, which helps you run dynamic hosted websites. We launched a new product called Firebase GenKit, which is a library that helps you manage, run, and operate your generative AI experiences that interacts directly with Vertex AI and Google AI. And we launched client SDKs for direct access to Vertex AI. So if you want to call Vertex AI directly from your client apps, you can do that with the new Firebase SDKs for Vertex AI. All of those products came out last year, and they are all maturing, moving towards general availability, and coming out with a lot of new features. So be on the lookout, as these are the ones that we are focusing heavily on building out for customers to build really immersive new applications, new immersive experiences for customers. We have additional products on the other parts of Firebase that I won't cover here, but those are the ones that are really top of mind for me right now. And so those are the major trends. I highly recommend folks tune into Cloud Next in April, where we will likely see many new updates to all of these products. I myself will be there, so if you are at Cloud Next and you see me walking by, come say hello. I promise I'm friendly, I don't bite, and I love engaging with folks about what kind of apps that they're building and the services they're using. So even if you're not using Data Connect, or if you're just interested, swing by and say hello to me. So folks, that was all of our questions today. We had a really great look at Firebase Data Connect. We understood what it did. We walked through a demo. We walked through the local tools, the production monitoring, the GraphQL. We used Gemini to generate GraphQL for us to query our database. And we even answered a number of your questions. So Thank you for having me today. It's been my pleasure to chat with you. There is a survey that you folks can take once this Cloud on Air is complete, so I recommend you go take that survey and give us feedback on how we did. And with that, my name is Tyler. I'm a product manager here at Firebase and Google Cloud. Data Connect was a product we went through today. If you have any additional questions or any requests, go check out the Discord to go engage with our team, and go look at Firebase User Voice to add feature requests for the product. And so thank you for watching, and I look forward to the next time I get to engage with you folks.